Hi there, and welcome back to the channel. I'm the GCSE science teacher, and in today's lesson, we'll be learning about the osmosis required practical for GCSE biology. If you do find this video helpful, please feel free to like, comment, and subscribe. It will be great to have you around. You can also find me on Instagram and TikTok at the GCSE science teacher too. If you share my videos, it always helps someone with their studies, so feel free to do that too. The question of the day then is, how did this happen? We have some raisins, and suddenly they've become more like grapes. Well, you've probably guessed it. They have been absorbing lots of water and become plump. And this is because of osmosis. A lot of times in baking shows, or if you've ever made a cake or something like that, you might have actually soaked some dried fruit in, say, a liquid like tea or something like this to add more flavor to your cooking. And this is because those fruits have been dried out, all of the water has been removed, and they can actually absorb that water again from a high amount of water molecules to a low amount of water molecules inside the dried fruit across a permeable membrane. This is what we call osmosis. If you want to learn more about different transport systems, I should say, in cells, you can feel free to check out my previous video on it. I'll link it for you. But we are going to specifically talk about osmosis today. So, just as a recap, osmosis is the movement of water molecules from a high concentration of water molecules or a dilute solution across a partially permeable membrane down a concentration gradient to a lower concentration of water molecules or a more concentrated solution. So, the aim of the practical, what do you actually have to do? And I love doing this practical with my students because it's very fun. Lots of students have questions about it along the way, which is great. So, the aim of it is to investigate the effect of a range of concentrations of salt or sugar solutions on the mass of plant tissue. You need to be aware, though, a lot of the misconceptions I find students have is that they forget that plants are made up of cells. They also forget that fruit and vegetables are also made of cells. Everything living has some sort of cellular structure to it. We also have a misconception here that a lot of the time students will do this practical on potatoes. There's nothing wrong with that. Potatoes are amazing, as we all know, but we can in the exam find they like to change the practical up. So sometimes they use a carrot or they use a I don't know, they use another type of vegetable or a fruit. Usually it's a vegetable, but that can sometimes throw students off in the exam and they will go, Miss, you never taught me this. I did. You've just got to apply your knowledge to a slightly different scenario, especially if you're doing triple science. So just be aware of that too. You also often are using sugar solutions like a glucose solution, but sometimes you could in the exam be asked about a salt solution. So just be aware of that. Sometimes they change the word of it and how it's called. So instead of it being a salt solution, they may say a sodium chloride solution. Instead of a sugar solution, they may say a sucrose solution. It's the same thing as you have learned in class. Just be aware of the different language because sometimes that can throw students as well. So, the apparatus, the equipment that you'll need includes a cork borer. Often, the technicians that are amazing in your school are behind the scenes making this practical for you. So, it's nice and easy for you to do. But a cork borer, if you do get the chance to use it, essentially you use this cylinder where you push into a potato or a vegetable and you get these nice, even cylinders. And that way, everything's uniform and able to be the same volume and size. Amazing. But they're quite tricky to use. So, be very careful. They can be quite sharp. A cork borer you'll need then. You'll also need the plant tissue, so a type of vegetable, often a root vegetable. A ruler, you'll need a measuring cylinder. You'll need labels or a pen to label the different boiling tubes that you'll use. You'll also need a boiling tube rack. You'll need paper towels. You'll need a sharp knife or a scalpel. Be very careful with this, obviously. If you are using a scalpel, make sure you cut away from yourself. That way you can prevent any cuts that you may get. Just be very careful. You'll need a white tile to do any cutting. And you'll also need a range of different salt or sugar solutions depending on what you're using. You'll also need distilled water and you'll need a top pan balance. And we're going to go into why you need all of this. There's a lot of different bits of equipment here, but you will need most likely to work with someone else when you do this, especially if you're doing this at GCSE, just because there's quite a few steps to do. So How do we do this? The first thing you need to do is you need to create 5 equal cylinders of plant tissue, and you can do this using the cork borer. You want to trim them so they're all the same size in length. I often go with around 3 centimeters so they fit inside the boiling tubes, and you do this using your sharp knife and your ruler to make sure they're all the same size. You also want to make sure that you remove any of the skin that is on the plant tissue or the vegetable, because that way all of the osmosis that is happening can be evenly occurring, because there's no like outside layer to the structural plant. Once you've done this and you've got all of your even cylinders, 5 is around a good amount. I've found in the past. I've done more, I've done less. 5, I think, so you can get a different range of solutions. You want to record the length of each of them, and you want to record the mass of each of them. Now, a lot of students will say, "But Miss, we've all cut them to be 3 centimeters, and therefore they're all going to weigh the same, right? Or have the same mass, I should say." Not always. Be very careful. You want to make sure that you check the exact mass of them and the exact length of them, because each of them are going to change slightly. Even if it's a millimeter or a point of a gram, that can affect your overall grade, overall results, I should say, because you're looking at the difference between the pre and post solution exposure. So you want to be very careful about how. Um, you want to make sure they're all accurately the same size, but you also want to make sure that you've recorded any slight differences, because your initial reading versus your final reading is what you're actually looking for. You're looking for the difference. So once you've recorded the length and you've recorded the mass of each cylinder, you record that into a table. You want to measure around 10 centimeters cubed of a 1 molar sugar solution, or it could be salt solution, and transfer that into the first boiling tube and label it as 1 molar solution sugar, sucrose. You want to then repeat the same thing for the other 4 concentrations and a distilled water. So in total, you could have 4 different solutions and a distilled water. You could have 5 different solutions and a distilled water. The distilled water essentially acts as pure water, and it just sees what the effect is when there is no sugar in there. It's just H2O. Um, like I said, those sugar solutions, you could do a zero point 0.5, a 0.25, a zero point 0.1 molar concentration, just the amount of sugar that's in there, or the amount of salt. Your technicians, like I said, they're amazing. They often will make this for you. Even your teachers often make this for you too. You may be asked at A level, if you are going to think of doing A level, you might be asked to create these yourself. But often at GCSE, you will be given these solutions. Um, so you want to add one of those cylinders to each of the test tubes, like I've said, or each of the boiling tubes, a bit bigger, a bit larger as a boiling tube. And you've labeled them all. And you want to leave these overnight, about 24 hours. Just leave them as is. You may even want to put a lid on the top, and that can prevent any evaporation of water that can affect your results. And then after the 24 hours have gone, you want to remove each of those cylinders with a pair of tweezers potentially, or you can just drain them out. And you want to blot them dry with those paper towels. And this just removes any excess liquid. You then want to measure the length and the mass of each cylinder and record those measurements in the table you'd previously written in. That way you can calculate the percentage changes of each cylinder and plot a graph against your results, so you can actually compare them. So let's have a look. Let's zoom into the future. We've done the practical and these are our results, and we've got to do some calculations, like I said. So first thing you want to do, we want to write all of our results into a table, which I've done here. So I've got concentration of sucrose in a molar concentration, which is 0.1. The mass of the potato cylinder, let's say at the start, was 2.43 grams, and the mass at the end was 2.51 grams. So it's gained mass, and that's because it's absorbed some water by osmosis. So to work out the change in mass, we want to do the mass at the end minus the mass at the start divided by the mass at the start. And that will give us an answer of 0.033. We can then times that by 100 to get an answer of 3.3% increase. And because it's an increase, we put a plus sign next to it. Now, one thing to be aware of, not all of your potato or all of your plant tissue will actually increase in mass. Some of them will actually decrease in mass. And I want you to pause the video here and think to yourself, why might the mass of the plant tissue decrease after being in that sugar solution? What might be the reason? Have a theory, write it down, hypothesize in the comments. I'd love to hear your answer. So if we then have our results, let's say we've calculated all the change in mass, we've done this as a percentage, and we have our results in a table, we can transfer this into graphical form so it's much more visually appealing. We can see here we've got a change in mass on the y-axis as a percentage, and you can see that the axis goes into a negative and a positive. That's very important because, like I said, you're going to have some of the plant tissue that actually decrease in mass too. You also have on the x-axis the concentration of the solution that you're using as a percentage, let's say, for example. Okay, you can also plot this as the molar concentration if you wanted to. It doesn't have to be percentage, that's fine. So if the plant tissue has gained mass, the change will be positive, as we've said. If the plant tissue has decreased in mass, the change will be negative. And this is because let's just clarify this. If there has been an increase in mass, the water has been absorbed, which means that the solution inside the cell has been much, much lower in water concentration than on the outside. So the amount of water on the outside of the cell has actually moved into the plant tissue. Okay, remember, osmosis goes from a high concentration of water to a low concentration. If the plant tissue has lost mass, it's because the amount of water molecules inside the plant tissue is much higher inside the plant than it is on the outside in the solution. So that means the water molecules have moved from the plant tissue into the solution, and therefore it has decreased in mass. You also will notice in your results that you'll see a line that will actually cross the x-axis, the horizontal line. And this is when there is an equilibrial state. So the concentration of water inside and outside the plant tissue is the same. So the net movement is zero. And that's really useful for working out the concentration inside the plant tissue itself. I hope you found that video helpful. If you did, feel free to comment, like, and subscribe, and share this again with someone you think would also benefit from learning more. Like I said, I'm on Instagram and TikTok at the GCSE Science Teacher, and that is me. I have been the GCSE Science Teacher, and you have been curious. So thank you so much for watching, and I'll catch you in the next one. Bye.